Okay? So here we go. We're going to pick up right where we left off yesterday. So that we're ready for practice test 1 still. And we're ready for 4B, which says solve this equation. Alright, who remembers how to do that? Square both sides. What a great plan. And when you square both sides, that's the kind of problem that you might have an extraneous root. So I think I'll check my answer when I'm done just to make sure that it all works out. Anyhow, so I got 3x minus 8 equals 36. So 3x equals 44, and x equals 44 thirds. How's that look to everybody? Great. Now, I want to show you something. Let's go back to the original problem. Look like this. That was the original problem. I'm going to put 44 thirds right here. And for that x. Now, before you panic, won't those cancel? So I have 44 minus 8, which is 36. And the square root of 36 is 6. So that checks. Remember the ones, a couple of the ones we did in our notes? Remember we got an answer that didn't check out? This is the kind of problem that can happen on when you do this squaring both sides thing. But that works, so that's the answer. Good to go.
Should we just check anytime we solve for x, or do you think that takes too much?
Well, actually, checking is always good because you might make a mistake along the way. But checking these kind when you square both sides, when that's what you do, is square both sides, that's when you might not make any mistakes but still get a bad answer. Okay? The other kinds of problems, like these kinds of problems, if you get the wrong answer, it's because you screwed up. There's nothing in the process that makes wrong answers. This process can make wrong answers. Okay, perfect. Next, what about this one? By the way, see that right there? That tells me that my answer, I'm probably going to use a number line, and my answer is going to be in an interval. So parentheses and brackets and things. That happens when you have inequalities. All right, so here we go. What's the first step to solving this?
Find something that adds up to 12 that equals 4.
So White's talking about doing this, right? Factoring it. So he says it's got to multiply to 12, and multiply to negative 12, add up to negative 4. So what do you think? X 6 and 2, and minus plus because I need the 4 to be negative. Perfect. Now what? So I'm going to put dots on my number line at 6 and negative 2, and they will be solid. And then pick a random number that isn't these two, so some other number. So what would you like to choose? 4. They said 4, so we'll pick 4. Now 4 is right in here. So what I'm doing is I'm checking to see if I should shade here. So let's put 4 in. 4 minus 6 is negative 2. And 4 plus 2 is 6. And negative 2 times 6 is negative 12. Is negative 12 bigger than 0?
No.
No. So what does that mean? Don't shade it, right? So I don't shade this part. It didn't work. It came out false. So I don't shade this part, which means what is going to be shaded? The outsides. Remember, with 2 dots on the number line, you're either going to shade outside or you're going to shade in between. Those are your options. So what's my answer? Got an answer blank there. Got to put something in the answer blank. What are you going to put in there? Negative infinity, negative 2, and the negative 2 will have a bracket because it's closed dot. We have our union symbol, our U. Then we have a bracket, 6 comma infinity, right? All right, what does A mean? This has been on a quiz or two. What does problem 5A mean? That means the distance. Bring that over here. So, bring it over here. So, AB will be a distance. And that's gonna be a couple of parentheses squared, that's what it looks like. And what goes in the parentheses? X minus X and Y minus Y. So X minus X, Y minus Y. So X minus X, 6 minus 1, Y minus Y, 3 minus negative 2. All right. 6 minus 1 is 5, squared is 25. 3 minus negative 2 is 5, squared is another 25. So I have the square root of 50. And anytime we see a square root, we should ask ourselves, can that be at all broken down? So let's see, 25 times, not 5, 25 times 2, and 5 times 5. So does that break down? Yeah, we got 2 of these. So what is my answer? What goes in the answer line? 5 radical 2, perfect. This comes out, that stays in, 5 radical 2. All right, how do we do part B? Find the midpoint. How do we do that? Midpoint is average. Oh my goodness, we've talked about that. Midpoint is average. So how do we average? Add them and divide by 2. So my x's, you're doing x plus x, you're averaging the x's. So 1 plus 6 over 2, and negative 2 plus 3 over 2. Add your x's, divide by 2, add your y's, divide by 2, so it looks like the midpoint is 7 halves and 1 half. Righto? All right, number 6. Write the equation of the line containing these 2 points. Okay, we've done that on 2 different quizzes, at least. Write the equation of the line containing those points. Okay, what do we do? So we find the slope. So slope is 15 minus 3, that's y minus y, over 2 minus negative 2, that's x minus x. So what do I got? 12 over 4, which is 3. That's my slope. Okay, we're not done though. That is not the end of the problem. You need to write the equation of the line, which means you have to pick a point. Okay, which one do you want to use? I don't care, it doesn't matter.
2 and 15.
This one?
Yep.
So y minus 15 equals 3 x minus 2. The directions don't say, so this would be fine. What form is this? This is a perfectly good line. What form is that? Point slope. If by chance you have to put it in the slope-intercept form, you just take that guy right there, distribute the x, or the x, the 3, distribute the 3, and add the 15 over. So that would be my slope-intercept form if I needed it. Again, for this test, the way it's worded right here, that would be fine. You can stop right there if you want to. write the equation of the line perpendicular to this one and containing negative 2, 1. So think about the problem we just did. The first thing we did was find the slope, right? Now we're going to do the same thing here, but we're not going to find the slope the same way. We're going to have to find the slope of this line, aren't we? And how do we do that? How do we find the slope of a line if we already have the line?
Put it into slope intercept.
We get y by itself, yep, put it in slope intercept form. Because if you can write your line like this, that guy right there is the slope. So we have to do that. So I'm gonna take 2x and move it over, I guess. And divide by negative 1. So what is the slope of the line that I've been given? Well, the slope of the one I've been given is 2. This is my given line. But I want the perpendicular in this problem. So what slope will I use? Negative, not negative 2, negative 1/2. Because when I do the perpendicular, I have to flip it and change the sign. So my slope is going to be negative 1/2. My point, I don't have a choice, it's this one. So y minus 1 equals negative 1/2 x plus 2. Using this point. And that's fine. That's point slope, that's absolutely fine. If you wanted slope intercept, it would be this right here. But this is perfectly okay. That's perfectly all right for this problem. Okay, so what was all this? What was all this work right here? There's a lot of work right here. What was they doing here? Finding the slope of the line they gave me. And that slope turned out to be 2. So when I wrote my equation, I used the opposite reciprocal. Now, what if the word in the problem had been parallel? Then I would have just used 2. Everything would be the same, except that would be a 2. Right? Okay, everybody keeping up? All right, here we go. Write the equation of the circle whose center is 6, negative 2, and the radius is 4. Anybody know what that looks like? No, double the radius would be the diameter, but that isn't what I put into my equation. You must remember, so put a star by this, kids, because this is going to be a test question, absolutely guaranteed. You're going to have to know how to write the equation of a circle. So the circle has an x quantity squared plus a y quantity squared equal to the radius squared. That's what circles look like. An x squared quantity plus a y squared quantity equal to an r squared quantity. Okay, so what goes here? Who remembers? If that's my center, what's going to go in here? X minus 6. And this is going to be y plus 2. And then this number is always r squared. So this number is going to be 16. Now this is a perfect example of a kind of problem where you don't really have to do any math. You just have to remember what the equation of a circle looks like. that just means you're in practice, study. All right, number 8, got our exponent problem. We're gonna simplify the exponent. Okay, so what do you recommend doing first? Okay, so Daryl says, I don't like this guy down here, so I'm gonna take him to the top. So now I have this. I already have a y. Now I have an additional y squared because he went up to the top. Okay, perfect. Don't like negatives, get rid of the negatives. Beautiful. All right, now what do you suggest maybe that we do?
Combine the y's.
You can combine the y's for sure. So that's a y to the first and a y to the second, so that's gonna be a y to the third.
Would you distribute the
Got a parenthesis sitting here. Don't we have this thing in PEMDAS that says take care of that? So let's see, what's that gonna be? 9x squared. And we've combined our y's into y to the third and 6x to the fourth. Okay, we're getting there.
the x to the bottom and then so it's just a 2.
So these guys are gonna cancel, right?
Yeah.
So I still have my y cubed up here, but now I'm gonna have x squared on the bottom. Because I have 2 of them over 4 of them. And then what about 9 and 6? We can divide 3 out of both of those and make that 3 over 2. Just regular reducing fractions. And that's our answer. Good? All right, last problem. Our handy dandy projectile motion. So there's the formula. Remember I told you I'd give you that every time. But you have to, part A, question A says, write the equation for this problem. So this is your general formula. What is the equation for this problem? You can use H equals, or you can use S of T. It doesn't matter. This is, okay, this is that. We'll turn it off. Who knows, but Tilly will go rescue us, because she knows how to figure it out. S of T is the height. So I call it H, you could call it Y, or you could leave it S of T, it doesn't matter. Then you're gonna have negative 16t squared. Now, do we have an initial velocity in the problem? What's our initial velocity? 20? Now, guys, you gotta make sure you get the 20 in the right spot. It says the velocity is 20 feet per second, so that goes in for V. Okay, that's your velocity. What's the initial height of the ball? 30? It's on a building 30 feet tall. So this is question A. And again, I don't care what you put here. You can put Y, you can put S of T, but something equals that. Okay? That's easy. Question A is easy. All right, B. When does the ball hit the ground? Okay, we did 2 of these yesterday. Do you remember? How do we figure out when the ball hits the ground?
We would plug in for time. Because we're trying to find time, so we plug in for the height.
Yep,
So
and what do we plug in for the height?
30 feet.
The ball's on the ground.
Oh, 0.
0. So we're gonna put 0 here for the height. The ball is on the ground. If the ball is on the ground, its new height is 0. This is the original height. That'll never change. That's 30. but this is the new height of the ball. It's gone up in the air and it's come back down. Okay? All right, now who remembers how to solve this?
I guess like when is the ball hit the ground?
Yep.
Graph it.
We can, absolutely, we can graph it. And when we graph it, I don't know what we're gonna see, we'll find out here in a minute. But we'll probably see something like this. And isn't this the point where the ball hits the ground? It might, it'll probably keep going. But isn't that the point that we're looking for? Okay, so I'm gonna zoom 6 to make sure that I got a regular piece of graph paper. And then I'm gonna type in my new equation. You must clear out the old equation. Are you gonna type with me? Negative 16t squared plus 20, and we're using x. We're using x's, not t. Okay, I actually saw something that looked like this. It's a little jaggeder, but did you see it go up and then it disappears and then it comes back down? Okay, so this is the point we want right here. This is where it hits the ground. It's gone up and it's come down and hit the ground. So second trace 0. The cursor is there, you just can't see it. So you need to take your arrow buttons and you need to watch where it is. Mine's at 0:30, so mine's way up here right now. So I'm gonna move it this way till I see it come back down a little bit. It sometimes takes a while, don't panic, you'll see it. Oh, there, I saw it and it zipped right by me. Did anybody get 2.130? So what is the answer to question B? What do I write in the answer blank? 2.130 seconds. Yep.
How did you do that? Exactly. Finding 2.130 on the calculator.
Okay, I'll go. We need to come in and get some help because we can't keep doing this. Second trace 0.
Yep.
Left bound, set the cursor over here. Right bound, set it over here. Guess, set it in here somewhere and hit equals. And it will come up. Okay, so if it's not, then that means we gotta work on that, but we'll do that individually. Finally, how high is the ball after 1.5 seconds? How high is the ball after 1.5 seconds? What do I do? It all comes back to this equation.
You add 1.5 to the y, or do the other box, right?
I do something with the 1.5. What do I do with it?
It's right for the T,
Put it in for the t. And Jared, why am I putting it in for the t?
because it's the time.
Because it's the time. And t is time. So I'm gonna put 1.5 plus 20 times 1.5 plus 30. Sometimes kids forget about this guy right here. Don't forget there's a t, a plain t, hooked to your velocity. So you're gonna put that 1.5 in twice. You're gonna put it in the squared spot, and then you're gonna put it in the regular spot. Okay? So now, we're not graphing now, we're going to do regular calculator, and we're typing negative 16 parentheses 1.5 squared plus 20 times 1.5 plus 30. How high is the ball? I think, if I typed it right, 24 feet?
Yep.
test one is done. Alright, so here we go, number 2. And you will notice that the questions on number 2 are just like the questions on number 1, in a different order maybe. And they will be just like the questions on your test. So here we go. Number 2A. Which property is shown? Look at it. Do you know any of them?
First one's additive inverse.
Additive inverse. Very good. That was on our last test, practice test. So number 1 is the additive inverse. It's an inverse whenever things cancel. So don't 15 and negative 15 cancel? Yep. I'm adding them, so it's additive inverse. Look at C. Do 15 times 1/15, do they cancel? What happens if you multiply 15 over 1 times 1 over 15? Don't they cancel? But I'm multiplying this time, so C is the inverse of multiplication. Yep, or you can just write mult inverse. It's the multiplicative inverse, but that's a bear to spell. So just do multiplicative inverse. And how do I know those are inverses? Because they cancel. Now, B does not cancel. What's happening in B? Associative of addition. We are adding and we regrouped, didn't we? So that's associative of addition. Perfect. Beautiful. Okay? Everybody got it? Number 2, A. What are you gonna do with this guy?
Quadratic. Or quadratic.
We could use the quadratic formula, or if you wanted, Jack, you could try to factor this.
Yeah, quadratic would be easier though.
It would be probably easier, quicker anyhow, more efficient. So what does the quadratic formula say? X equals negative b, which will be positive 1, plus or minus the square root of b squared, minus 4 times a times c, all over 2a. Right? So what's happening? Now let's see. First of all, you see this 2 negative thing going here? That's going to be 1 plus whatever that is. So that's 24, 48.
Yep.
So what's under my radical? 49. That's nice. What's the square root of 49? 7. Now, when I write 7, it's not the square root of 7, it's 7. The square root of 49 is 7. So 1 plus or minus 7 over 12. That simplifies. 1 plus 7 over 12, 1 minus 7 over 12. If it simplifies, you have to simplify it. So this is 8 over 12, which reduces to 2 over 3, divide by 4. This is negative 6 over 12, which reduces to negative 1/2. So what goes in the answer blank? X equals 2/3, X equals negative 1/2.
When do we know when to like plug in to check and see if there's any extra?
It never hurts to check, okay?
Okay.
You have to check when you square both sides. If
Okay.
you have an equation that you square both sides,
Okay.
which we didn't do here. All right, B, what's our strategy with B? Okay, and we get rid of it by writing two equations. And since there's one of these, I know my answer is going to be intervals, parentheses, and brackets. So this answer was x equals 2/3, x equals -1/2. That was it. This one's gonna have to have parentheses and brackets because it's going to be on the number line, shaded. Okay, so first equation, x plus 2 is greater than 7. What's my second equation?
Minus 2 is greater than.
No, x plus 2 less than -7. And since it's a great or problem, we're gonna put an or in there. And solve. So x is greater than 5. X is less than -9. Bless you.
Bless you.
Okay, I did that kind of fast. Everybody keeping up there with that part? Subtracting 2 from both sides? So how do I write my answer? Anna, you got an idea how I might write my answer there?
Would it be negative infinity, comma, -9, and then parentheses, and then the union sign, and then 5, comma, infinity.
Beautiful, beautiful, beautiful. That's perfect. Absolutely perfect. Everybody got that? Okay, so let's make sure we're all clear on when do we have to use this kind of notation for our answer? We don't always do this. When do we do it? Whenever the problem is a less than or greater than, right? That means you're gonna have a set, a whole set of answers. Begin. Okay, next, C. What do you think about C? Phoebe, what's your plan on problem C?
Get the same denominator.
Yep, and what would you suggest we use for that denominator, Phoebe?
24.
You absolutely can use 24. I don't want one person in this room to think you can't use 24. You can use 24. Could you use anything else? You could use 12. Now, but Phoebe, don't worry about it. Use whatever you want, and 24 works fine. In fact, just for fun, I'm gonna do 24, and we're gonna see that it works out fine. So if you're gonna change them into 24s, you're gonna times this one by 6, and that's gonna be a distributive. You're gonna multiply this one by 4, and that's gonna be a distributive. And then we're not gonna forget that this also has to be a 24, so we're gonna multiply him by 24. We did that, Phoebe did that, so that now the denominators are gone. So 12x minus 6 plus 4x minus 8 equals 48. If you use 12, is anybody doing 12 as common denominator on your, okay, good, good, keep going. Because yours is gonna look a little bit different than mine, but our answer is gonna match exactly. Okay, keep going. All right, so I've got 16x minus 14 equals 48. So I add these together, add these together. Add 14, 16x equals, is that 62? So x equals 62/16, which are divisible by 2, so 31/8. Is that what you guys got? Using a smaller common denominator, using 12, keeps your numbers a little bit smaller, but in the end, it's all gonna come out. It doesn't matter. beautiful, beautiful. Okie dokie, what's next? More solve. Yeah. Okay, so what do you think?
And so less.
I would factor
It's a less than, so I'm gonna have an answer that's an interval, I'm gonna use a number line. I heard somebody say factor it, does this thing factor?
Yes.
So x
Minus
Minus
one.
minus 4 minus 1, which means on my number line, my solid dots are going to be at 4, positive 4, positive 1, so 1 and 4. Good. Izzy, do you remember what to do now?
now we're gonna pick a number.
Pick a number. What number would you like to pick? 3? So she's picking 3. 3 is right in here. So what is she doing? She's trying to figure out if I should shade here or not. Okay, so let's put 3 in. So 3, they're putting 3's in here. So 3 minus 4 is negative 1. 3 minus 1 is 2. Is negative 1 times 2, which is negative 2, is negative 2 less than 0? Yes. So since negative 2 is less than 0, what does that mean? I shade it, and I'm done. Because remember, we either shade in between or we shade out. We shaded in between, so therefore our answer is bracket 1, bracket 4. I hope you're starting to feel like this isn't so bad. All right, next. What do I do with this guy? Square it. Now I'm gonna check my answer when I'm done, because this is the thing that causes issues sometimes. When I square it, I get x minus 2 on this side, and 25 on this side. So it looks like x equals 27. So I'm gonna check that. I'm gonna go back to my original problem. I put 27 in for my x here. Is that a true statement? Is that right? 27 minus 2 is 25, and the square root of 25 is 5. So there's your answer. No number line, no interval, just x equals 27. Oh, now the big one. Lucy, you remember how to do this? Huh?
I don't know.
You don't know? Okay, we gotta figure it out, 'cause it's on the test. Leslie?
You group the, like, two equations.
So we do what we call factor by grouping. So we're gonna group those two together, and Leslie, what can you take out of those first two?
2x.
X squared?
X squared.
Yeah. And that will leave us with
X plus 3.
beautiful, absolutely beautiful, perfect.
Then,
All right. Keep going.
and then negative 4.
Yep, take out a negative 4, so watch carefully.
And then it's gonna be x plus 3.
Beautiful, because we took out a negative. All right. Now, there's my common factor. And there's my x squared minus 4. Oh, that was my phone. sorry about that. Can I do anything with that? Difference of squares. And then I gotta write my answer in the answer blank, which will be no intervals, it's just an equal, so x equals what? -3. Kids, I'm kind of doing that automatically. Remember, at this point, you have to say x plus 3 equals 0. If that equals 0, doesn't x have to be -3? And then x equals -2? Or x equals +2? And the order of those doesn't matter. I just put them in order I have a factor, but you can put those in whatever order. Okay? Four A, tell me what's happening here. I'm subtracting. I'm not foiling, I'm subtracting. So 4 minus 2i minus 6 minus I, what will be my answer? What goes in the answer blank? -2 minus 3i, very good, that's it right there. Done. Okay, now B is a little bit tougher. What do I do with that?
What would you say that as taking the denominator and multiplying it? It's something to do with, it's 2 positive 3i.
Yep, it has something to do with that, exactly. What do I do with 2 plus 3i?
Put it next to it and then you can put up top and bottom.
Exactly. So I am gonna multiply the top and the bottom of this fraction by 2 plus 3i. And you don't need to know this for the test, but that's called the conjugate. I multiply top and bottom by the conjugate. So this was the original denominator. So I change that sign and I multiply top and bottom by that. Now, what does that mean I'm gonna have to do? Foil. This is gonna be 2 foils now. Foil on the top and foil on the bottom. So here we go. On the top, outside, or excuse me, first, outside, inside, last. First, I'm gonna do the bottom now. Outside, inside, last. Okay, take a minute and clean that up for a second. I'm afraid the music's gonna play, so I wanna be standing here ready to click this off the minute that comes on. I don't wanna get arrested. It might not, but you know, when that bell rang, made me, or the dinging, whatever, made me think this would happen. But it would have started by now. Wouldn't it have?
You never know.
You never know, I know, it's like, you never know. Okay. So, how'd you simplify? Did you add these, I hope? And that gave you an 18i. What's this? -9. So 8 and -9, I got -1 plus 18i on the top. Or 18i minus 1. And then what's on the bottom? Those are gone. This becomes a +9, so 13. right, so another exponent. Everything on the practice test is on the test, so we know you're gonna have an exponent problem, just one. You have to simplify it. All right, so Deshaun, what would you want to do first?
X's.
You wanna combine the x's? We absolutely can, the x's can combine. So how will those combine? You have 5 of them on the top and 10 of them on the bottom. So they're gonna cancel out and leave you with 5 on the bottom. Everybody good with that? All right, what else needs to be done?
The 4 and 12.
The 4 and the 12 reduce like regular fractions. So what, 1 over 3, perfect, did you need me?
Yeah, but no big
Okay.
deal, I'll wait
That's
for
right,
you.
they can finish this, they know what to do next.
Okay.
Right, people?
Yes.
You know what to do next.
How are you today?
Okay. All right, wait a second. Now what do I need to do? I need to do something with my y's. Tell me what you did.
Add 3 to the top.
I hope you moved this guy to the top. So then you had your y to the 8th, and now you brought up a y to the 3rd, which gave you a grand total of y to the 11th. That 1 can stay or go, doesn't matter. If you like it there, leave it. If you don't want it there, it doesn't have to be there. Okay, now we did that problem in a very different order than I would have done it if I were on my own, but the answer is the same. As long as you get all that done, it doesn't matter what order you do it. Write the equation of a circle. We talked about this earlier. Some of you really need to study this so you get this figured out. Circles are an x squared quantity plus a what? Y squared quantity equal to a what? Radius squared number. That's what circles look like every time. Oh, hello. Okay, so now we are going to plug in our center. So our center is 2, -1. So this will be x minus 2, y plus 1, and our radius is 5, so this equals number is 25 r squared. That's the problem. You don't have to even do anything, kids. You just plug in the numbers. All right, number 7. Write the equation of the line. And our points are 2, 4, and 1, 6. Here we go. Step 1.
Square root.
No, be careful. What's the big square root? I do that on some problems, but that is distance. I am writing the equation of the line, okay? So, Louis, what do? What do? Yes, you. So, I'm finding the slope. So, 6 minus 4 over 1 minus 2 over, so -2. All right, that's step 1. Okay. Jade, what's step 2?
We plug in 2 for the slope, so it would be y minus 4 equals -2x Oh wait, sorry. Yeah, -2, and then in parentheses x minus 2.
Okay, so Jane picked the point, she picked this one. So y minus 4 equals -2 x minus 2, perfect. Can I stop there? Yes, I can. Now, if you wanna go on, go ahead, but don't make any mistakes. It's okay if you go on, but don't make any mistakes, because that's it. That's good enough, right there. B, last one today, problem B. Write the equation of the line, so we're gonna do what we just did, but this time we wanna be parallel to this one and contain the point 2, -3. So what do we do?
Move those, so move this x over.
We gotta get y by itself, right? And then these out. We gotta get y by itself. So, I'll subtract the 6x. So -3y equals -6x plus 10. These don't add, please don't add those. It's -6x and 10. Then I'll divide by the -3. Did I get 2x? And this number really doesn't matter, because why am I doing this? Just to find that guy right there, because he is the slope, right? That's all I need. Now, if I'm going to be parallel when I write my new line, then I will use that slope, right? On the last practice test, we wanted perpendicular, so we used -1/2. But this is just going to be y plus 3 equals 2 x minus 2. So there's your point. So it's y minus -3 equals 2 x minus 2. Okay, so we'll pause there. All right, now we gotta look at our calendar, because we're at one more review day, and then we're gonna take our test.